Good evening and welcome. I'm Arthur Evans. I'm the CEO for the American Psychological Association, and I would like to welcome you here to the last in our series, our 125th anniversary series, speaker series. We have another great speaker, Dr. Brian Nosek, that you'll hear from in a moment from the University of Virginia Center for Open Science. As many of you know, APA is a major publisher of, in fact, the largest publisher of psychological literature in the country. And there's probably nothing that will impact on our publishing more than open science and the open science movement. And so we're very fortunate to have Dr. Nosek here. We have a memorandum of understanding with the center, and I'm sure you're going to talk about that tonight, or you're going to hear about that tonight, and we're just very delighted to have you. He's going to be more formally introduced in a moment, but I wanted to thank all of you for coming to our series, and again, we look forward to hearing a really great speech. Thank you.
Hi, thank you for joining us for this final talk in APA's 125th Anniversary Distinguished Speaker Series. For those of you who are watching online, please feel free to leave questions in the comment box below the video. And for those of you who are seated here, please feel free to ask questions at the end of Brian's talk today. I'm Rose Sokol-Chang. I'm the journals publisher at the American Psychological Association. And tonight I have the pleasure of introducing Brian Nosek, a professor of psychology at the University of Virginia, Charlottesville. He's also the co-founder and executive director of the Center for Open Science, and he's a co-founder of Project Implicit, which is an online space for research and innovation on implicit social cognition and unconscious bias. Brian received his BS at California Polytechnic State University in psychology with minors in computer science and women's studies. And then he went on to complete his master's and his doctorate at Yale University in experimental psychology. Brian has done extensive work to develop open science practices and improve reproducibility in psychological science over the last several years. In 2013, he was co-guest editor of a special issue of Social Psychology, a journal, and it was focused on replication of important results in social psychology. In 2015, Brian co-authored the Reproducibility Project, an attempt to replicate 100 pivotal experiments in psychology. For this work, Brian was named one of Nature's 10 people who mattered in 2015, and was on the Chronicle of Higher Education's influence list. A similar large-scale attempt to replicate high-profile studies in cancer biology is underway, and the first 5 of 30 studies have been repeated and published this past January. Brian has been on the list of highly cited researchers from Thomson Reuters 3 times in the last 5 years. Through his work with the Center for Open Science, Brian has co-authored the Transparency and Openness Promotion Guidelines, to which more than 500 journals have signed up. The Center for Open Science also hosts the Open Science Framework to connect scholars across the entire research cycle. This includes a data repository, and we are excited that the Center for Open Science will soon host a data repository to connect data to articles published by the APA. In 2015, Brian co-founded the Society for Improvement of Psychological Science, a society committed to improving methods and practices in psychological science. An early project produced by members of the society is a psychology-specific preprint server called PsyArchive. And we're also excited that PsyArchive is our preferred preprint server for APA journals. Today, Brian is going to talk about a culture shift toward openness and reproducibility in psychology. Please join me in welcoming Dr. Brian Nosek.
Thank you very much for coming and for having me for this event. It's great to be able to speak here. You might have heard that there has been a crisis in psychology, real concern about the credibility of our published literature, of the extent to which it's reproducible, worries that the research that we're doing is too low powered to detect the effects that we observe in the literature, Almost everything in the literature is a positive result, which doesn't make any sense given what we know happens in the lab and the power of the tests that we have, that we're misusing statistics and ending up inferring results that aren't actually there. We're employing flexible practices in how we analyze our data, how we share our data, what we selectively report. And all of these have the potential impact of making the literature that we see less credible than we think it is. Of course, this crisis that I'm referring to is the one that came up in the 1960s and 70s and was discussed in detail by scholars like Jacob Cohen, John Tukey, Tony Greenwald, Paul Meehl, Robert Rosenthal. They discussed all of these issues. Low power of the research, Jacob Cohen was most known for, selective reporting of what results occur, the prejudice against the null hypothesis. Tony Greenwald is a famous 1975 paper. Lack of replication was a constant theme in many of them, and misuse of statistics was a dominant discussion among many more, just a sampling of citations in the slides. So, how'd it go? There was this crisis back then. Surely we've solved it then and got to move on. And so we can look at least at one of the examples. Jacob Cohen, in his 1962 paper, said, we have a power problem. The average study's power to detect the effects that they should be able to detect, that they say that they detected, is only 0.46. Much too low for what we would consider to be reasonably powered studies. Sedlmeier and Gigerenzer, 25 years later, said, let's see how we've improved, because now that we know that power is a problem, surely we've gotten better. And of course, they found that the average power was no different. In fact, if anything, slightly lower. So in 1992, Jacob Cohen reflected on this insight that he had about power and what has changed. And I'll just read part of it here. Like many men my age, I mostly grouse. My harangue today is on testing for statistical significance, about which Bill Rosenboom, 1960, wrote 33 years ago. The statistical folkways of a more primitive past continue to dominate the local scene. So he was commenting that we've known about this stuff for a long time, and yet nothing has changed. A similar example is the change of how we think about and use statistics. And it was known in many of these papers in the 60s and 70s that we should really not be focusing so much on p-values, but we should also start to incorporate things like effect size. How large are the effects? APA started in its fourth edition of the APA guidelines, started to recommend that we should be using effect size alongside p-values. This paper that came out in 2000 said, well, let's see how it went. Have we improved on our sharing of effect size? And what they found was that a growing corpus of empirical studies of published articles portrays a consensual view that merely encouraging effect size reporting has not appreciably affected actual reporting practices. So they found no change in the degree to which researchers were reporting effect size. On the positive side there's a dissertation, Sun 2008, that does report some change in the proportion of papers reporting effect size. So we had this crisis, 60s and 70s, and what happened? Well, not a whole lot happened. But now we have this new crisis in the 2011 through present. Oh, no, it's the same crisis. It's the same crisis. Okay, it is the exact same set of things that come up in all of these papers over the last 6 years that were discussed in all of those papers in 60s and 70s. It's amazing. I have my slides up at the end. You go to those original papers by Tony Greenwald and all of the others, and it is as if you're reading them today. They are just as relevant to the issues that we are wrestling with today as they were then. And they're all the same core problems and the same suggested solutions. So this isn't a new issue. It is the same issue of how is it that we can best pursue methodology to best pursue the advancement of our research. It's not totally the same. We've also added new pictures about these issues, so we've turned it into a circle. and now we have some new words like harking and p-hacking. So there is a difference, right? There are things that have happened to say that this is occurring throughout the research life cycle, and we have a sort of a better understanding of where it's occurring. So it's not all repeat. Okay, so the question then is, if we had these insights 40, 50 years ago, why is it that we're having the same discussion today? Why haven't these practices changed when the problems were identified and really the same solutions for many of these issues were identified in those prior methodological articles? Well, I think there are a couple of key reasons. When we have had this issue in the past, we've done a lot of things in thinking about how is it that we change behavior. And most of what the prior work had done is to say, let's figure out what it is that we need to change. The way we're using statistics isn't quite right. What do we need to do better? Our power is low. What do we need to do better? How do we do that? Well, we increase our sample size. We increase the strength of manipulations between conditions. We increase the reliability of our measures. No, why? Why? Well, because we'll get to better inferences. We'll learn things faster. We'll be more efficient with our research overall. So the way in which the problem and the solution were understood was a matter of education. People just don't know what the right practices are. We'll write a bunch of papers identifying what the right practices are. Then people will do those practices and science will get better. But what a lot of the interventions in our past did not do was appreciate the other elements that are critical to behavior change. We have a very mature science of behavior change in our discipline, and it says that this is not sufficient. These may be necessary. You need to know what to do. You need to know how to do it. You need to know why you should do it. But you also need to have the means of changing your behavior. You have to have some way in which you could enact that change. You need to have a culture that supports those changes. If it's actively resisting you changing your behavior, then you can't act on your own inside that culture. And we need to attend to the incentives. Not just the why in terms of the conceptual why, but the why in terms of how is it relevant to me in terms of the reward systems that drive my behavior. So my case today is that our science of behavior change for behavior change of ourselves is maturing rapidly. So what is different today than was different in the last iterations of the crisis is that as a community, we are attending to our own science and applying it to ourselves to improve how it is we do our research and come to inferences. So the core point is that the insight I think we are gaining as a discipline is that the challenges we have for reproducibility, for the credibility of our research, are not just understanding the statistical issues, not just understanding the methodological properties of how the research gets done well, not just teaching people how to do those things, but also dealing with the psychological challenges of a scientist doing science and the cultural context in which that scientist is embedded in engaging and doing their science. And so that's what I want to unpack today, both on the challenges and then on the solutions that I think are showing some impact. So let me say what I mean about that cultural context and norms and expectations, the things that go beyond just the knowing how to do it. And we can start with thinking first about what are the values of science? How is science supposed to be as we characterize it as a means with which we discover things, we learn things about the world? And Robert Merton described in the 1940s and 50s what he perceived as the norms of science, the ways in which science advances knowledge that make it distinct from other ways of knowing things about the world. The first norm he identified was communality, the open sharing of information. When I make a claim, for it to be a scientific claim, I can't just say, this is what is true and you should believe me because I'm an authority or because I'm super confident in how I say it, so believe me. A scientific claim is one where I show you how I arrived at that claim. Here's the methodology that I used, here's the data that I generated, here's the inference process that I made, and so that's why I arrived at that claim. That way you get to look at it and say, no, or, oh, that makes sense, or what about this, what about that? And that process of debate and discovery is the way in which science gains credibility in its claims, as opposed to secrecy. Nope, just trust me. I got this. Just believe me. Trust me. Another norm is universalism. Research is evaluated, we evaluate the research based on its own merit, right? Rather than the particularism. Oh, that person's famous, they must know what they're talking about. Okay, I believe that claim. Right? A scientist is supposed to be disinterested, right? Motivated by knowledge and discovery, just trying to figure out how the world works, versus the counter norm of self-interestedness, right? All I'm here for is to get ahead of the person down the hall, trying to advance my career against those, the others that are also doing it. A researcher practices organized skepticism, right? So what I'm supposed to do in my research is look at all the evidence, whether it challenges or not my prior claims, and revise my claims based on the evidence, be responsive to the evidence, and skeptical of the claims as I start. Versus the counter norm of organized dogmatism, where I get my finding in my dissertation, I have my theory that I generated, and I spend the rest of my career defending that theory against all of the attackers around me to see how long I can help it survive. So Merton identified those as sort of four core norms, and while he didn't identify it, many others have talked also about a norm of quality as compared to the counter norm of quantity. Right? So these are some percepts, some principles by which we think, at least Merton thought, science is supposed to operate. So one of the cultural factors that we can consider is, do researchers themselves endorse that? Do they think that these are the ways in which science should be done? And Anderson and her colleagues asked. They've surveyed 3,300 or so NIH awardees. Early career here is postdoctoral positions. Mid-career are people who are in their first R01 award, so average age around 40. And this is just a cumulative plot of their responses of which one do you endorse, the norm or the counter norm? And what you're seeing is the gray bar, 90% of people said that they on average endorse the norms over the counter norms. And in black, a very, very small proportion said, no, I actually think science should be according to the counter norms rather than the norms. Right? And then the slashed, there's still a few people that sort of weight them equally in what they believe. So people are saying almost universally, we embrace the norms of science. So then they said, okay, that's great. Don't tell me what you believe, tell me how you behave. Tell me what you do in your research. Right? And it looks like this. So still about 60% of people are saying I behave according to the norms of science, but more are acknowledging that the counter norms also carry some weight, that they are competitive, they do keep some things secret, et cetera. And still very, very few are saying that they behave according to the counter norms over the norms. So they say, okay, that's fine. Don't tell me what you do. Tell me what the other people in your field, what do they do? Looks like this. So this is kind of a big deal because it's the same people, right? We are surveying, we endorse the norms, and we perceive that the others of us don't behave according to those norms. That in fact, they're doing things, they're holding stuff secret, they're being dogmatic about their principles, they're just treating it as a competition, they're acting in self-interest, advancing their own careers at the expense of scientific advancement, right? That is, as we know in work on norms, this is a big gap. If I perceive the culture around me as one that behaves according to norms that I don't believe in, that I don't endorse, then my own behavior, how do I respond to that? Right? Especially if those counter norms are career advancing, but not science advancing. Well, what I end up in a situation is that I am confronted with a choice. People around me are just doing things to advance their careers. That's not what I believe. But if I want to do what I believe, if I want to behave according to the norms of science as I believe them, then what I am doing in my perception is selecting to do things that will disadvantage my career progress. Right? So that's a very tough situation to be in because I could say, okay, forget my principles, I'm going to make sure I have a career. Or I could say, I'm going to hold on to my principles and sacrifice my career advancement. That's a very difficult situation for behavior and behavior change. What we think is the core challenge that needs to be solved in terms of the psychological and cultural constraints on behavior in doing science is that the incentives for my success are focused on me getting it published, not on me getting it right. Right? I need publications to advance my career. They are the currency of science. So the more that I publish, the more prestigious the outlets that I publish them in, the more likely I am to get a job, to keep a job, to advance in my career. And because of that, the key incentive then is getting it published. And as we know, not everything gets published. Some things that I do are more likely to get published than other things. I'm more likely to get published if I find a positive result rather than a negative result. I'm more likely to get published if I find a new finding, something that changes how we understand something rather than repeating something that somebody else had done. I'm more likely to get published if all of my evidence is neat and tidy, tells a clean story about that phenomenon, than one that has exceptions, things that don't quite fit, the theory that doesn't quite align with the data. So a positive, novel, tidy result is the best kind of result. Those are jackpots in advancing science. But of course, in the lab, how often does that happen? It doesn't happen very often because we're studying hard problems. That's why we study them. So what we get in the lab is a lot of uncertainty, a lot of things that are exceptions, a lot of stuff that doesn't quite fit. And all of that is part of the discovery process, is part of us internally learning about how it is that phenomenon works. But all of our incentives are tell the best story you possibly can so that you can get it published. And so all of those problems that were identified in the 1960s and 70s, flexibility in how I analyze the data, flexibility in which things I choose to report, all of those things are opportunities for me to make my results in the lab more publishable at the expense of the accuracy of translating what's in my lab group versus what's in the paper. And I might not even do it intentionally because I didn't get into science to publish papers. Anybody get into science because they say, I want to publish papers, that's what I want to do? No, no one got into science for that. People get into science because they're curious, they like figuring things out, they like problem solving, they have a mission on a particular big question. There's lots of reasons that are about truth, that are about figuring things out, that are what got people into science. So my motivations, my intentions are pure in how it is I do my research, but my realities are I need to get certain kinds of things in order to get advance in my career. So that creates a whole bunch of barriers to changing my behavior, to live up to those values, to being more open in my research, to making my research more reproducible at the end. One of those is the perceived norms we just talked about, this fact that I perceive the community as not aligned with my values. And so how do I live according to my values? A second is construal level. Right? Construal level talks about things that are abstract being more distant, harder to live up to. So the principles of openness, of self-skepticism, these are abstract principles. So how do I use those abstract principles to drive my behavior? It's not so simple. What's a lot simpler is the concrete things to drive my behavior. The concrete things like get a publication. That I can get my mind around, and because it's concrete and it's proximal, it's close to me, I can do those things. Those will tend to dominate my decision making, the things I need to do to get a publication, rather than thinking about the principles that I'm trying to use to guide my behavior in general. A third factor is that I have these amazing frontal lobes that when I see a result or two possible results and one of them looks better for me than the other, then all these machinations start happening where the one that looks better for me in terms of publishability seems like the better result, seems like the right way to have done it. And that result that comes out of some method that doesn't look good for me, I suddenly realize, oh my gosh, that method was totally messed up. I can't believe I did that study. That's a terrible study. Let's put that one aside. Right? So we can use our reasoning tools to rationalize many of the decisions in terms of things that will align better for our own interests rather than for more general interests. We are motivated to find particular things compelling. Also, you don't know what happens in my lab. You don't get to see it. So I operate with very little accountability to outside perspectives. And we know a lot about the absence of accountability. If I don't think people can observe my behavior, then in those situations of ambiguity where I could make many different choices, it's going to be a lot easier for me to make the choices that are self-interested. Whereas if I know someone else might be watching, I'm more likely to take a perspective. How would they perceive the decisions that I'm making now, and use that to sort of moderate my own behavior in what decisions I choose to do. And then finally, I'm busy, so are you. Right? There's a lot of things to do. Our lab is working really hard all the time, just trying to get work done. And so many of the solutions that we could imagine of being more open with our data, sharing our things, pre-registering our designs in advance to make commitments, those seem like and are like more work. And I just don't really have time for more work. So this is a big set of barriers to actually changing behavior. And it would be great if that were easy, but it's not easy because there are lots of different groups that are driving the incentives that shape my behavior. Each of us has a unique constellation of different groups that hold our incentives, that guide our behavior, right? The universities that we're in for getting hired, for advancing our career, where the journals that we publish in have their own guidelines and policies for what it is that I need to do to get that reward, the funders to try to get the grant awards, and the societies that set those norms. And all of these are decentralized. So the big cultural challenge is that each of these different communities sets their own rules, their own policies for how it is you get the rewards through that system, and they aren't beholden to each other. And so if we want to move a culture to be more supportive of the values that we have for science, openness, transparency, reproducibility, then we need to solve the coordination problem. How is it that we can get all of these different groups to move together so that all of them are shifting what that constellation, that culture that constrains and provides opportunity for that researcher to be able to do things. So it would be amazing if there was a discipline that studied things like motivation and the effect of culture on behavior and how you change behavior. Oh, wait a second, there is a discipline, that's us. Psychology is the discipline, right? The real challenges of changing behavior that in scientific practices to promote openness and reproducibility are psychological problems. They're our wheelhouse. And so part of the reason I think that psychology is so far out in front of addressing these challenges is because we know about these behaviors. We have insight on this, and so we can use ourselves as a test bed to figure out how we can continue to do it better. So let me transition into what it is we should change, right? If we're talking about these as challenges, what is it that we would like to change in our culture, in our behavior, in order to be producing the most robust science as quickly and as efficiently as we possibly can? And we think that we can actually narrow this down to two very simple things. There are things that we learn in kindergarten. And if we can do those two simple things collectively and at scale, then our science will be a lot more efficient. And it's these two: show your work and share. That's it. We don't need to tell researchers how to do their research or how to make inferences. We just need them to show us collectively how they did it. And the marketplace of ideas that is science will sift through it. Scientists, as you might know, are really good at being critical of things. If you've ever had reviews of a paper you've written, you know that scientists are really good at being critical of things. And so to take advantage of that skill, of the fact that we can each be skeptical of each other's ideas, all we need to do to make that as efficient as possible, as effective as possible, is for people to actually know what you did to get to those findings. So if it's just the claims in the paper, and I don't know how it is you got to those claims, I can't see the data, I can't see the process that you used to make those inferences, then I can't make an informed critique of the paper. And so showing your work is just giving others the opportunity to actually credibly evaluate what it is you did. And sharing your work, making that data available to others, making your methodologies available to others, makes it a lot easier for others to reproduce and extend that work, to do new things with it so that we can be more cumulative in our process, make it easier to replicate other people's findings so that we can actually build a science, evidence upon evidence, rather than everybody working independently and just hoping we influence one another. So our goals with the Center for Open Science are really to try to foster a culture that embodies these two qualities. Samin Vazir, I think, captures this well in a paper that she wrote recently. I think it appeared in Nature. Without data transparency, assessing a study is like buying a used car without being able to look under the hood. We wouldn't do that in buying a car because we know we don't know how this thing works. We don't have the history that went into this car. We need to be able to see what it went into it in order to make confident inferences about it. David Donahoe, who's a faculty member at Stanford, likes to call the article advertising for the research, not the research itself. Right? It's the author's best presentation of what it is they think they did and what it is they think they found. But the actual research is the data that was generated, the methodology that generated it, and the process of making inferences from it. That's the research. And we need to be able to see that to truly evaluate the evidence and its implications for us. So let me go through a couple of examples of these other elements that we haven't previously appreciated, but I think there's growing appreciation for, of what we need to do to more effectively change the research culture. And first is having the means to share. How is it that we can actually be more effective in sharing? And there are a number of practical barriers that researchers face for actually sharing their data or their materials, their code, things that they produce in their research. One is that they're not organized to share. I wasn't thinking I was needing to share this. I have this ad hoc system of just maintaining my own folders, which I lose all the time for my own use anyway. The grad students leave and I have no idea where anything went because they had their own organizing system for how it is they maintain that. I have collaborations all over the place and who knows where the data are anymore. I can't even use it for my own purposes. I don't have time to get all of that together and manage it and do all of the things that I would need to do to share it. And, really, I put a lot of work into collecting this data. I'm not really ready to share it. So why are you asking me? I want to do more things with it before I will share it with you. These are practical, realistic barriers that researchers face in deciding that it is time to share. And so one of the key things that we have been working on at the center is to try to lower the barriers to sharing, make it easier for researchers to be able to share their work if they choose to do so. And all of this is embodied in the Open Science Framework. And so this is a free open source tool for researchers to set up accounts, create projects in those accounts, add their collaborators to those projects, and then put their materials, put their data, store their IRB files, everything associated with that in a cloud-based solution to archive all of that material for their own use. But the key is that they can use that privately for as long as they want. So they don't have to make anything public. They use it to manage their own projects so that they don't lose their own data, their own materials, their own things for their own use ever again. And so the OSF tries to solve these practical barriers by providing a service that's useful to researchers for things that they need now. I don't want to lose my data for my own use. Okay, so let's solve that problem. Let's make it easy for you to register your things so that you can, for your own use, have confidence in what your plans were and what they became over time. And so the OSF deals with these by providing project management tools, make it easy for researchers to organize themselves as they do their research. We integrate the OSF into the research lifecycle. What we usually think about in terms of things like, I need to share my data, is something that's after the fact. Now that I've published, now I need to organize my data in order to be able to share it. That's a very bad time to ask people to share data because they got their reward. I've published the article. I don't want to think about this data anymore. I'm done. I'm moving on to the next problem. But if we can actually help researchers curate that data along the way while they're actually working on the project, then transitioning it to be open data is a lot easier because they already have done the work before they got to the end of the project. And then finally, I'm not ready to share. Well, that's fine. Share when you're ready. And so what the OSF does is it allows an entirely private workflow to exist that we use in our lab. And then anytime that I'm ready, whenever it is that I'm ready to do it, I can make some of my materials or data or projects public. Sometimes we make it public right away. This is a project we're going to do. Sometimes we make it available once we sort of have something, okay? And then sometimes we hold things because we have more that we want to do with that before it. But all of it is integrated in the same workspace. So what we're doing privately in the lab is fully integrated with the things that we've made publicly available. And we work with all of those for us in the same environment. And the public then only has access to the things that we made public. So all of that infrastructure is meant to support researchers being able to manage their research themselves, but also enables interfaces that groups in the community can use to enable their communities, to encourage their communities, create a culture that supports sharing at different phases. So I just want to give a couple of examples of that in action. SPSP, the Society for Personality and Social Psychology, has for the last 4 years used the meeting service. This is a simple view of the OSF that's just for sharing posters and presentations at meetings. And so they send out alerts for attendees. If you're presenting a poster and you want to share it with other people, just send it here, and then it's publicly accessible. And so they have a page with all of the different posters that people themselves decided to share. And then anybody, not just the 5 people that came up to your poster during the evening session, but anybody, anywhere, anytime, can get access to that materials. Right? So it's just cultivating in a very simple way, cultivating this idea of sharing. Why did I do this research? Well, I did this research so that other people would read about it, be influenced by it, think about it, do something different with it. And we have, it's hard to see from the room, but the top download from the 2017 conference is 424 downloads of this poster. Now, has anyone ever had a poster where you had 424 people come up to you and to talk about that poster? No, no one's had that. But you make this stuff available to people that aren't at the meeting, then lots more people can be influenced by that poster, that interim research product. It's a very simple thing, but it's a simple thing that cultivates that sense of the reason I'm doing this work is to share it, is to have others think about it, be influenced by it. A second example Rose mentioned earlier is PsyArchive. So the Society for Improvement of Psychological Science started the PsyArchive service as a preprint sharing service. Can we make it easier for researchers to share their research when they've written a report, but prior to it going through peer review and getting published? Maybe sharing it earlier, you'll get other kinds of feedback that you wouldn't have gotten or would have taken longer to get in just waiting for peer review. So it both accelerates the speed with which people in that discipline can find out about what you've been doing and gives new avenues for getting the kinds of feedback and critical commentary that you want to maximize the impact of your work. So that is as a service is something that they offer for anybody that wants to share papers earlier, can log in and post a paper very easily on the framework. And then other groups like APA have partnered with that and say, if you're going to share a preprint, here's a service that you can use, alerting authors to that. And we're working on ways to facilitate easy deposit, submission from a preprint service into the journal workflows so that researchers can have an easier time of getting from concept of I have a report to publication, the end result of what I need. So this is just an illustration of the preprint once it's posted. So you fill out 5 simple steps, a preprint goes up, and then anyone that has that can find that URL, you share it in social media, and people start downloading it. So this is just one example of one that was posted a few months ago. Already 131 people have downloaded and read it. Or maybe they read it. Maybe they just downloaded it. I don't know what they did with it. Okay. A third example, Rose also mentioned, which is you can use the OSF as a repository, and we can create views that make it easy for researchers to share their data. And so APA will have a branded repository for any authors of APA articles. You can say, would you like to share your data? Here's an easy way to do it, and give them a streamlined process from at that point of having their article accepted to making their data behind that article available. If they want to and if they can. There's lots of occasions where data can't be shared, but for those occasions where it can, making it easy for researchers can just streamline the process and provide that sense that the culture supports this. The societies and the journals that I publish in think that this is something of value. And so maybe it's worth me doing it. Okay. So that's culture support. Another element goes specifically on those incentives. Yeah, it's great that there is that service, but why would I use that service? What is it that I get as value for being more open, being more sharing of my work? Well, here I just want to give a few examples of things that we have tried and found to be effective. One is a very simple one, which is badges. So when I get my article accepted at a journal, if the journal offers these badges for open data, open materials, or pre-registration, they say, now that you have your article accepted, if you'd like to make your data available and you meet the specifications for earning the badge, we'll put that badge on your article. Little gold sticker for having done such a nice job sharing your data, right? If you pre-registered your research, we'll put that on there and we'll put a link to the pre-registration. Now, when most people look at badges, they either think Girl Scouts or I don't need no stinking badges. And those are reasonable reactions. That seems silly. At the same time, the badges are signals. And we know a lot about signals in psychology, right? We know that providing simple signals gives information about what someone else is thinking, what someone else values, how it is what they do in the world, right? So lots of ways we signal things. The clothes we wear, bumper stickers on cars, animals do this in the wild. Providing signals of strength, of virility, whatever it is, are easy ways to communicate information at a distance. And in this case, they're communicating something that already is valued. There is value. We saw the endorsement of these kinds of practices in the earlier slides, right? People value openness. They just don't see that when others are doing it. So if we can provide a signal, that might actually increase the likelihood that people will actually follow through with the behavior. So the first journal that adopted the badges was Psychological Science, and they did so on January 1st, 2014. What I'm showing you here on the y-axis is the percent of articles that reported that the data underlying the article was available in a repository. And on the x-axis, what's showing so far is from 2012 through 2013 for Psych Science in black, and then for comparison journals. So the data sharing rates are average about 3% of articles made their data available in a repository from 2012 through 2013. Badges were implemented at Psychological Science on January 1st, 2014, and this is what happens. By the first half of 2015, 39% of the articles in Psychological Science reported having open data in a data repository. Right? There was no change in the data sharing rates of the other journals that didn't adopt badges. Right? It's a 13-fold increase, right, in that case. That's a very simple intervention. It's just a matter of giving people a signal that this journal cares about it, that's why they're offering it, and that here's a way to do it, and here's a little indicator that you did it. Right? If just that is enough to get people to shift, a lot of people to shift their behavior, then what it illustrates is not that badges are so powerful, it's that those values are powerful. The values are already there. We just needed a mechanism to show when it actually is happening, to make it an indicator that other people can see. Because I want to show that I'm practicing the most rigorous, the best science that I can. And if there is any way to indicate that, to show that, then I'm more likely to follow through with it. So there are a number of now journals that are offering badges for researchers, so we have more opportunity to evaluate whether this is a replicable phenomenon itself, just of what happened at Psychological Science. And APA has just started initiate invitations to journal editors so that they can do the same across the APA journals. Okay, one more of these general examples, which is giving terminology, understanding of what is it that openness means. How is it that people can be transparent in their research? Providing a framework so that because there's all of these decentralized players, different groups and different stakeholders, we need to give them a common sense of what it is that we're trying to get researchers to do. And so the way that we pursued that was to create the top guidelines. And this was a community effort of a number of different people from different stakeholders, communities, that generated 8 standards, sort of consolidated all of the existing approaches to thinking about transparency, and generated 8 standards of these are behaviors that researchers could do to be more transparent with their research or to be more reproducible with their research. And by organizing these into 8 independent standards, what it provides is a framework for any research across any different scholarly community to say this is how it is we could encourage, as a funder of our grantees, as an institution of its employees, as a journal of its authors, what you can do to be more open and transparent, reproducible with your work. And a key part of this was to provide flexibility for those adopting stakeholders so that they can meet the needs of their cultures. They don't have to push in a single way. Everybody has to have open data now. Some communities may not be quite ready for a requirement like that. And so each of the guidelines has 3 levels, and you can adopt whichever level is appropriate for the current context that you're in. So a level 1 of data sharing is just disclosure requirement. You have to state, so imagine it's a journal, the article has to state whether the data are available, and if so, where to access them. Just say, is it available or not, and if it is, where? That's it. Level 2 is a requirement. So the data must be posted to a trusted repository. And if you have reasons that are intellectual property or privacy concerns with this data, you just have to say in the cover letter when you submit the paper, I won't be able to share the data, and then the editor gets to make a judgment. Is that a reasonable justification for not doing data sharing in this case? And as long as you have a sensible editor, then they will evaluate it appropriately. The third is the most stringent requirement. So you have to, not only do you have to share the data, but someone will independently verify that the data that you shared actually is able to reproduce the findings that are reported in the article. So that's a heavy lift. There's a lot more that goes into adopting a level 3. So very few journals or funders are going to go to that extent, at least right away. So it is much more aspirational than active now. So this has been a successful way to provide a common framework that works not just in psychology, but across many different disciplines, so that all of these different groups can say, we have a way in which, a language with which we can talk about promoting this. And the individual actors that have their own unique societies and journals and funders and everything else can have a common sense of, oh, these are the principles that are driving these expectations by this journal, and understand that easily. So we have more than 5,000 journals that are signatories to the top guidelines, about 80 organizations, and you can see a variety of them in psychology and everywhere else. Thank you. Okay. I'll do a brief of a last one and then make sure that we have some time for questions. So this again is on incentives, and the examples that I've given so far are focused on once the research is done, just showing what you did. There is another important principle that has emerged as being critically important for the robustness of research, which is the planning stage. What is it that I think I'm going to do in the research? And this can be illustrated, the importance, by referencing what occurred in the world of clinical trials a number of years ago now. There was recognition at some point that in clinical trials, pharma companies and the researchers doing the research might have a conflict of interest in the research that they're doing to get this drug or therapeutic approved into production. Right? There's a lot of money to be made if they can get the approval process through the FDA. So there's recognized that conflict of interest means that if researchers have all this flexibility for how they analyze their data and what they end up reporting, then they may exploit that flexibility, unintentionally or intentionally, in order to get approval and then make lots of money as a consequence. So what should we do? Well, a group of journals got together that are journals that publish clinical trials and said, we will not publish a clinical trial unless it has been registered in advance. You have to put it in a registry, say what you're going to do, say what the outcome variables are, so that when it is published, we can look at the registration and we can compare it with what's in the paper and see, did you do what you said you were going to do? Or did you change all the outcomes? And did you leave out studies that you actually did a trial on and just didn't report it because they didn't have convenient results? So doing that was a means of injecting accountability. The researchers, we need them to do the research, we need them to fund doing that research, but we also need transparency of what they're doing and how they're doing it. So Robert Kaplan and Veronica Irvin wanted to see what happened once pre-registration wasn't introduced. And they started with an initial study. This is a small initial study of research of large trials that were done at the Heart, Lung, and Blood Institute. And their key outcome was to compare what was the rate of getting positive results, evidence for the effectiveness of that therapeutic or drug prior to pre-registration being required versus after. And the summary result is that the positive result rate was 57% prior to pre-registration being required. Most of the outcomes were showing that the drug or whatever was effective. It was 8% after pre-registration required. Right? A massive drop. It is a small sample, and it also is not a randomized trial. Right? It could be that in these this research area, they discovered everything that they were going to discover prior to 2000 when the rule was induced, and then there was just nothing left to discover. So all of the clinical trials failed because there's nothing left. That may be true. Some people think it's not likely, but Kaplan and Irvin are following this up and trying to see if they can replicate this finding in other areas. So that's a prelude to the point that I want to make, which is about the role of pre-registration. And I'll just cover this briefly, but the pre-registration as a process has as its role to distinguish two modes of research. Right? In one mode of research, I have an idea, and I want to go get some data to test that idea, to confront my idea with the possibility of being wrong, or to find some evidence that's consistent with the idea. Say, oh, that idea is worth holding, right? That hypothesis has some support. In that mode of analysis, I'm in the context of justification. I'm using data to test my hypotheses. And so the choices that I make about how I am going to test my hypotheses are independent of the data. I make them blind to the data so that the data can then confront my hypotheses. The other mode of analysis is the context of discovery, where I'm in the data and I'm using that data to generate possibilities. What might be going on? So my hypothesizing is responsive to the data itself. I'm exploring, and I'm getting inspiration from that data for new hypotheses. And pre-registration makes it very clear which mode you're in. The things that you write down in advance, before you see the data, are your hypothesis tests. They're your confirmation. I'm using this data to confront myself with these initial ideas. Anything that's done, analyzed with knowledge of the data, is in exploration mode. I'm using the data, and it's influencing my choices for how I analyze it. Why is this important? Well, it's very important because the tools that we use for statistical inference are only useful on the left side. The use of statistical tests and the p-value is hypothesis testing, null hypothesis significance testing. And why it's only useful on the left is because the interpretation of the p-value depends on knowing all of the tests that you did, all of the tests that you could have done or would have done, having seen the data. And so you can only estimate that without having seen the data. Once you see the data, then its influence on you means that lots of different paths that you might have taken to analyze that data are no longer taken because you've seen the data and you've been influenced by it. And so the p-value in exploratory mode has unknown diagnosticity, whereas we know how to interpret the p-value in confirmatory analysis. We know how unlikely those events are, and we can correct for the number of tests that we did. So that has critical importance because if we present the results of exploratory research as if it was confirmatory with hypothesis test, then we're more likely to get publishable results because we're just searching, we're taking advantage of chance, and we're leveraging that chance in discovery. But as a consequence, we're reducing the credibility of those results. We're more likely to end up with false positives because we're more responsive to things that look like positive results. And so this puts the researcher in a situation of a conflict of interest. When I'm in exploratory analysis, I will find things that are better for me, and if I reason myself into thinking that with hindsight bias, that I probably would have thought that all along, then I might present it as if that was my expectations, as if it was a test of a hypothesis rather than as discovery. So that's the core rationale for pre-registration. We can talk more about that because I gave the very brief version. But what we've been trying to think about is how can we incentivize people to try pre-registration? This is a new thing. People do planning for their research, but they don't formalize it, write it down, and certify it to then confront themselves with it later. And so we create an education tool, essentially, and provide a workflow to allow people to pre-register their research and to learn about pre-registration along the way through what we call the pre-registration challenge. And as an incentive for people to start thinking about, maybe I want to try that, is we offer $1,000 awards for researchers that end up publishing the results of a pre-registered study that goes through this process. And so this is, $1,000, well, I could, send myself or send a member of my lab to a conference. We could have big lab parties, whatever it is that people want to do with that, great. But it really is just to get people thinking about, over that initial hump of maybe this is worth trying for the next project. So that's one approach to try to get people engaged with the process of pre-registration. Another is to integrate pre-registration with the things that researchers already are trying to do anyway, publish their research. And so the registered reports publishing model is a mechanism for integrating pre-registration with publication, the process itself. And so this is the cartoon version of how research happens, right? We design a study, we collect and analyze the data, we write up the report, and then we publish it. But of course, it's not quite like that, right? There's this big thing that gets in the way, peer review. After I've written my report, the peer reviewers are there to say why it's terrible and why it should never be published, at least never be published in this journal. And then I just go from journal to journal until I wear reviewers down and they say, fine, publish it. Register Reports makes one key change to this, which is to move the key stage of peer review from after the report is written to earlier in the process, after the design. So what happens is that when as an author, I submit my research question and I say why it's an important question that needs to be answered, that needs to be investigated, and my methodology. How is it that I'm going to test that question, those questions? And what the reviewers and the editor do is say, is that important? Do we need to know the answer? And are they doing a good job of trying to seek that answer? And if it passes those stages of review, then they make an in-principle commitment. If you follow through with your research in the way you described it, showing that you competently did the study, we'll publish it regardless of the outcome. Even if it's a negative result, we will publish it because we need to know the answer to the question. So we care about getting the result rather than getting something that looks beautiful. And then at the second stage, after the report, the peer review is not about, is the result sexy, exciting, whatever else, it's, was the research competently performed? And then that's the decision for publication. So this integrates pre-registration right into the publishing process. You are making commitments in advance of what your methodology is and how you're going to analyze it. And then anything else that you do as follow-up analysis, that's great. Do exploratory analysis. You'll discover things that you didn't think of. But then in the paper, just make sure that's just clear. Here's the confirmatory tests. Here's a new section of results. Here's all our exploratory things that we think we might have new ideas about to test in the future. It also changes the incentives for reviewers and for authors. Right? I don't have to focus as much on making my story as beautiful as possible in the report phase. All I have to do is make the best design that I can. And the relationship with peer reviewers is actually much more positive and collaborative, because it used to be that I would just send my paper with all my results and the reviewers would say, this is all the things you did wrong, and I'm up the creek. I did them wrong, but the research is done. When they give that critique here, here's all the things that are wrong with your methodology, I say, oh, okay, how about I change it? And they say, oh, how about this? And they say, oh, how about that? And then eventually we get to something where we say, yep, that's a good test. So I can actually use their feedback and have it shape the research and make much more effective research projects as a consequence. Okay, so I want to wrap just by showing we've got some issues, we've got some possible solutions. Just want to show some evidence that things are changing, that these have, because there's so much energy across the psychological community, that there are, the culture is shifting, and that shift is accelerating. So these are just data that I have access to of things that we are working on, but there are certainly many other indicators that others that are working on these issues could show too. So just some examples from the OSF. Here's the curves of over time from when we first launched the services in 2012 to the present, 2017, of the number of registered users, showing nonlinear increase, the number of projects made public, the number of studies or projects registered on the service, accelerating rapidly. People going to the OSF. So I put my stuff up there. Does anyone care? Well, this is just the last year of monthly downloads and views of content that other people posted on the OSF. So in October of 2016, there were about 50,000 downloads, in blue there, of content that was shared on the OSF. In this past September 2017, that's almost 300,000 downloads of content on the OSF in a single month. Right, so a 5 times increase over a single year. And a lot of people are accessing the materials that others made available for whatever reason. Right? They're reading it, they're reanalyzing it, they're using it for other things, they're just looking at it, who knows what they're doing with it. The preprint services, PsyArXiv is one, but there are many of these preprint services. And this is just showing the last 6 months of growth. It was about 2,500 preprints posted on the service. 6 months later, we crossed 5,000. We're at something like almost 5,500 as of today. That was a week ago. We just get a lot more happening. PsyArXiv is just about to hit 1,000 preprints itself. It's the one in greenish there. Users and sessions, so just people coming to the OSF over time. You can see from the onset to the present, sort of slow growth, and it is really dramatically increasing over the last 6 months. Number of journals offering registered reports. So the first journal that offered registered reports started to do so at the beginning of 2013. We now have 75 journals that are offering them, and we're getting a lot of data about how it is that this is going to share with other journals that are considering it. Okay, so let me close with noting that we have a lot of opportunity because the kinds of issues that we're wrestling with improving transparency and reproducibility of research, are the things that we know a lot about, that we know how to change behaviors. We know how the culture shapes behavior. And we can evaluate the effectiveness of our interventions. So all of the examples that I mentioned should be evaluated continuously, because as we make changes to how we do our science, we may have some consequence are the things that we desired, and other consequences that we didn't anticipate that might lead us away from efficient and effective research. So there's, with all of the energy that we have for reforming the different practices that we have, we need the similar energy on evaluating whether they're working. And if they aren't, not do those, right? If we can cultivate the sense of skepticism about our own process of how we do science as we do about the science that we end up doing, we will end up being so much more efficient with the resources that we have and so much more accelerated in delivering on the promise that psychology offers to figure out things about how humans work and how humans can work better with each other and on their own. So just want to point some information if you'd like to get more things from us. At the Center for Open Science, there's a link to our strategic plan. If you'd like to download these slides, there is a link to it. Take a picture fast. And I'll put that back up. And what I also have in the slides are things that you can do If we're going to shift the culture, it is a collective action problem, and we all need to be participating in our own ways. And so there's a number of things that I reviewed here that are actions that you can take yourself at whatever your role is in the research process. So I'll put this back up, and then you can find those more particularly. So thanks very much for your attention and your time. I appreciate it.
So if anyone has questions, we have time and we have a microphone that we can pass around.
Hi, great presentation.
Thank you.
As someone trained in experimental psychology, I loved it. So my question is when you talk about the difference between doing more confirmatory work versus exploratory work, I suspect that most of the psychological literature, most of the p-values that have been reported, probably on the exploratory side, right? So I'm just wondering about how you think we should be interpreting and understanding a literature that is based on more of those exploratory types of studies that probably don't have, as you said, the uninterpretable p-values.
Yeah, it's a great question, is what do we do with the past literature? We haven't been pre-registering everything for the years that we've been doing this work. Is it all bunk? No, of course it's not all bunk, right? We have made a ton of progress in many different dimensions. We could all give our favorite examples of things where we have built a body of knowledge, even though we haven't been pre-registering our research. And certainly it's the case that we have been, in different ways, doing some confirmatory testing, not just exploratory analysis. At the same time is we don't know which is which. Even my own papers before pre-registration, I don't know if I made different choices in those papers that I wouldn't have made if I had pre-registered my design. I can't show you that I didn't. I can't show myself that I didn't. And so that does increase the amount of skepticism that we might have of saying those are probably more tentative than what we could have if we had pre-registered them, if we had a strong ability to verify the confirmatory tests. So that's just to say that it's not that we should ignore our prior results and start over, like, okay, wipe our hands of that. More that of those things that we have any uncertainty about. The Stroop effect, I'm pretty certain that one happens, right? That one happens because like every time I do it in a classroom, everybody has the Stroop effect happen to them, right? So there are some things that are very repeatable. There are other things where we might have some questions. Say, the evidence isn't as strong, as repeatable as I thought it might be. So those would be where I would focus our attention. That stuff matters. That finding matters. It's still influencing us. Let's do a couple of confirmatory tests to really solidify our confidence in that. So, thank you. Yes, here.
How specific the reproducibility findings that you have are to the social sciences, psychology in particular, versus medical sciences and others?
Yeah, it's a great question. Is to what extent are there reproducibility challenges across disciplines, and is there variation? And the simple answer is, I don't know, but there's more than that. So there are some reasons to think that that reproducibility challenges are going to be pervasive, that every discipline is facing it. And the reason to expect that is that the incentive challenges are the same across disciplines. There are fewer jobs than there are people in every different discipline in science. And so the pressures for getting positive, exciting results are the same. And so that would create those conditions with that culture for it being more likely to produce irreproducible results. Simultaneously, there are reasons to expect that there's some variation, even within psychology, for example, that there be variation in reproducibility. So for example, in domains, just talking within our field, where it's very easy to collect data. So psychophysics experiments, I only need a few people to test whether this thing occurs, and then I can repeat it very, very rapidly, right? Vision research, right? If this phenomenon occurs in one person, we think it probably will occur in other people, right? And you go to a vision conference, the person shows an illusion, and then everybody goes back to their hotel rooms and reproduces the illusion for themselves. Oh man, that's cool, right? So it's highly reproducible and very repeatable very quickly. you can gain confidence in those findings very fast. Whereas when data collection is hard, or the inferences are hard, or it's a very open landscape with not clear sort of theories that provide constraint, then that may be a place where it's more ripe for irreproducibility challenges. So those are hypotheses rather than, and that is what explains why we see variation in reproducibility. But everywhere where people have bothered to look for reproducibility challenges, they found them. So that is a repeatable phenomenon itself. And so we have, I think Rose mentioned our reproducibility project in cancer biology, which we are just finishing up. So there are very similar kinds of challenges in that field as we see in psychology. There's a group of economists that have done similar things in economics, similar kinds of challenges. So it is pervasive, and there may be reasons to find variation as we get more data. So thank you for the question.
Not a question so much as an observation. I was struck by the pre-registration slide.
Yeah.
When you shifted over, that to me is a lot like what happens with the dissertation, right? You
Yes.
put your design there.
In
you
register
what you're
report,
doing,
yeah.
That's what you are. Yet the incentive, we learned very quickly, those don't get published easily. And so right away, the incentive path is set for pre-registering what I'm going to do and only do the confirmatory stuff that's been shot out of the water. Because
Yeah.
the rewards that we don't get in terms of publication.
Right.
So how do we change that then?
Yeah, it's a great question because it is true that the thesis defense is essentially, in most cases, a defense of your pre-registration, right? This is what I'm planning, and you get lots of feedback and improve that design. So that provides an opportunity at least of, oh, as soon as I finish that, then I just put it on an independent repository so I can show what I did. But the challenge you raise is a real one, which is, turns out most of the things we thought were going to happen didn't happen. And the current incentives are I need to find positive results in order to get it published. And so there is a paper that actually compared dissertations reports with the papers that came out of dissertations and showed that the papers get a lot prettier than was actually in the dissertations themselves, presumably in order to be publishable, but that's an inference. So those challenges are real, and we don't solve those unless we can also solve how journals make decisions about what gets published. And so the beauty of registered reports is that the journal makes a commitment before they know the outcomes. And so some editors are really worried. Well, geez, if I adopt that, then I'm going to end up with all these null results in my journal, and then I lose my impact factor, and then I'm the one that destroyed the journal because the journal impact factor goes down. So we're doing an evaluation study right now to see, is at least the hypothesis correct that the findings from registered reports will be less cited than other findings in the same journals. So we can evaluate if that's even a true hypothesis, and then debate about if it is, whether that is fine or not or whatever. But there's a lot of challenges to still pursue that. Thanks. This one over here.
Thanks for a great talk. I'm curious if you're looking at scientists, and you clearly are along where they are in the stages of change model to move toward this new model and new incentives. How impatient are the federal agencies? How impatient is Congress to get us from here to there? And how impatient are you to move scientists along?
Certainly more impatient than federal agencies are, I am. There is pervasive interest in improving on these issues. And that's pervasive across disciplines. It's pervasive across stakeholder communities. Certainly the federal agencies, as they were in the US, are increasingly motivated to do something about this. And Congress has awoken to these being issues as well. Now, of course, there's a variety of different responses for what people think should be done to address them. But the common interest of we want to be better stewards of the resources that we have to devote to science is a great one, right? Let's capitalize on that motivation. Let's also capitalize on the motivation that we want to get to the answers, make progress on cures, solutions, and otherwise faster. Okay, let's start with common ground. and then debate about the various implementation practices. We like to characterize ourselves in terms of patients as incremental revolutionaries, right? We do have an end in mind, right? Everything is open, and we just have a marketplace of ideas where we're fighting about which of it's true and which of it's not. And we just make sure that that marketplace has the data with which to operate efficiently. Simultaneously, there are a lot of things that need to change across a lot of different communities, and there will be unintended consequences, right? So one possibility with registered reports, this model, is that I, as an author, may be much more conservative. If I'm trying to get you convinced that I'm going to test something that I have to get commitment in advance, I might get more conservative, the editors might get more conservative. And so we lose something about the creativity in science. It's possible, we have no idea. So we have to try. So what I'm hoping is that we essentially cultivate ethic of experimentation, that we don't just accept our process of scholarly communication as it is. We say, let's try things that we think might do better and just have constant evaluation and keep the things that work and dump the things that don't. Thanks for the question.
Some questions from Facebook.
So this is a little bit long, but I think it's a good question. Thanks for the great talk. It seems all good sharing practices will have positive but limited effects unless publication practices massively incentivize them. Registered reports seem to be by far the best way forward for all the reasons you mentioned. So what are the prospects for the other journals offering them soon? What about the second best option, journals explicitly incredibly favoring designs that have been pre-registered, not as registered reports, materials, and data shared? How are we going to get there?
It's a great question of how is it that we can actually get to shifting the incentives enough that null results are valued too. There are some good reasons presently to devalue null results. And that is, in a world where low-powered research is pervasive, null results don't provide as much information as positive results seem to. But it's actually a problem for both null and positive results, low-powered research. We just have an intuition that it's only the nulls that are less interpretable. But in both cases, we have lots of uncertainty. So one of the things that journals can do to be more confident in accepting null results is changing the mindset from this discrete, did it work, did it not work, is it a positive or is it a null, to how much evidence did we accumulate? How much confidence can we have in the finding, whatever the finding is? How wide are the confidence intervals where we have precision of that estimate? And so there are a few things that journals can do that will feel less risky than starting to just say we're publishing null results, which is we're expecting higher power. We're paying attention to sample size and start to incorporate those in decision making. And I think that in part, that will naturally shift the resistance to null results because people will realize that robust designs with pre-registration, with precision of estimates, provides a lot of information about a question that if the question's worth answering, whether there's something there or not, or how big it is. So register reports are accelerating. We got a lot of, 79 journals so far. I'm hoping that we'll get more because I think that will be important. And the rest, still a big unknown. Thank you.
Do you consider some incentives for the research community to engage more in result replication, which become even more of a problem once this data availability becomes more widespread?
Yeah, so incentives for replication being important in the community, right? Because there aren't incentives to do it now. Repeating what someone else did isn't going to advance my career as much as finding something new. So I think it is important to create incentives for replication. But it doesn't actually have to be a ton of replication, right? So even though that's what we spend a lot of our time doing, I think if we got to, for example, federal funders putting aside 2% of their budgets to support grants for replication, that would deal with a lot of the what is needed for replication research. And the reason for that is that the things that really need to be replicated are those things that are changing the course of a field, right? That new amazing finding that said, whoa, if this is true, then all of this stuff should occur. And so we start to build a whole new, funding agencies build a whole new line of research support for that amazing finding. New fields start to emerge from that amazing finding. Those are the areas that if we targeted replication funding for, that we would gain rapid confidence that this is a reproducible finding or what's required to make it reproducible, or say, nope, that one was exciting, but we actually can't get it. And so let's not put our resources there. So the easiest mechanism, I think, to encourage that is for funding agencies to have funding lines that are specifically about propose why something is really important to replicate. We will put aside a small amount of funds, and it's really for promoting replications of important results. And the justification process is why it's important. The Dutch agency, NWO, did that, and they have put aside 3 million euro, I think it was, this past year. And they just announced in the last few months the awards for replication studies for that. The thing that journals can do is do special issues of replications that are important for their particular subdiscipline. And we did this, I think Rose mentioned this as well, we did this in 2014, a special issue of the journal Social Psychology, where we just put out a call. This was a demonstration of registered reports. So they had to submit their proposals. We did it as registered reports just to show that this is a viable model. And the acceptance criteria was the quality of methodology and whether they could justify that that's a good study to replicate. We need to know, have more confidence or more precision in what's happening in that work. And we got tons of submissions for that. So people are willing to do it if the incentives line up for them to actually engage with it. So thanks for the question. There's one over here.
Can you talk a little bit about the peer review process right after the pre-registration, how that's been going since people started pre-registering?
Yeah, so we don't have a lot of information about the peer review process after people just pre-register on their own. So you can go to the OSF and pre-register and then submit your research whenever you want, wherever you want. But the registered reports model, we do have some evidence because it's actually, we've been tracking within the system, right? They're submitting their pre-registered design and going through peer review and then following up when their research is done. And the short summary, and it's more anecdote rather than comprehensive data now, but the short summary is that papers are much more likely to succeed in getting through peer review with registered report because of the possibility of revision. There's almost every paper that's submitted, not every paper, most papers submitted have a seed of something really nice. And reviewers, when they can actually impact the design of that study or the shape of the question, are more likely, I think in this context, to give feedback to encourage it. Oh, if you did this, did you think about this? How about change it this way? And so Chris Chambers, who is the head of the committee for registered reports, I think he reported that across the journals where he is facilitating this process, that they've had an 80% acceptance rate in the end. Sometimes lots of back and forth, but 80% compared to 20% acceptance rate for the traditional process. So that should be a good incentive, right? 80% chance of getting through, all right. I will really know that I'm bad now when I don't get through. I'll make it through, I'll make it through. So that is very encouraging, that it is much more collaborative and responsive to getting it published. There is still, at the second stage of review, reviewers who will come back and say, oh, findings aren't that interesting, reject. And the editor has to remind them, no, you don't get to do that. We don't reject because of the findings. Did they mess up anything in the methodology? No, the methodology is great. Okay, we're publishing it. So there is still some of that hanging on to, well, it has to be an exciting result, doesn't it? Not always. Okay.
Thank you, Dr. Nosek.
Okay. Thank you very much. Appreciate the time.